Hello, everyone. My name is Michael Grant. I am the head of product for TrueFort. We're a cybersecurity software company focused on application protection. I want to welcome everyone to H-ISAC 2021. The topic I'm going to talk to you about today is how to reduce your attack surface with a different approach than you may be thinking, an approach that we call Application-Centric security. And we're going to cover that in a few ways. One, I'm going to talk to you a little bit about some of the reasons why reducing your application attack surface should be one of your top priorities. We'll talk a little bit about where the typical infrastructure-centric approaches don't really deal with the application risk problem. And specifically, we'll get into what is application-centric security, cover some real-world examples. These are real healthcare companies that are solving their security challenges around applications, specific use cases. And then we'll talk about a little bit at the end about just what you should look for in some of the solutions that may be available to you. So let's dive in and we'll talk about what you guys probably already know, which is healthcare is under attack, literally. Attackers and hackers are aggressively targeting healthcare. I think everyone at this conference is probably well familiar with the statistics that I'm going to quote here. But last year, even during a pandemic, there was a 55% increase in healthcare cyber attacks. 43% of all breaches were targeting the healthcare industry last year. And many of these breaches were dormant for a long time. Effectively, healthcare companies did not know they'd been breached. The average number of days to detect a breach was 96. And the attack vectors are all the greatest hits, phishing and ransomware being two of the highest, ransomware being particularly problematic for the healthcare industry. But we're seeing all the usual suspects, all targeting getting healthcare records primarily. And, one of the questions often is, well, why target healthcare? Opportunistically, hackers and attackers see medical records as a flexible all-in-one identity theft package. So they're going after healthcare aggressively. The good news is that cybersecurity spending has been increasing. Awareness is obviously high for these cyber threats. So spending in the industry by healthcare concerns on cybersecurity is increasing. The bad news is that the problem is getting bigger. And as the problem gets bigger, healthcare security teams are under continuous pressure. And that pressure is increasing. Again, as you know, the CIOs and healthcare concerns are challenged by, a range of new initiatives, new business initiatives, everything from new business models, new ways of delivering point of care, migrating legacy applications or on-prem applications into the cloud, effectively, deploying more APIs in support of more interoperability and connectivity to support those business initiatives. IoT devices now, becoming smarter, needing to connect with backends. The list goes on. And at the center of all these initiatives are applications. And applications is where you have a huge challenge, a huge problem for a few reasons. One, effectively, you've got increasing digital workflow coming out of these applications, digital transformation initiatives being powered by these applications. And as all these things interconnect and all these applications communicate, the pressure on the security teams to stay secure couldn't be bigger. And in fact, the folks who are following this closely are all pointing the red flags at the fact that attackers are becoming more sophisticated and they are targeting applications. The applications are where the data is. And if the applications are compromised, then effectively as these new digital transformation initiatives and digital workflows that come online, are compromised, then you can effectively grind operations to a halt. So what is the cost? Well, the cost right now is high. Attackers are going after these applications and data, and in 2020 alone, the breach costs from application compromise and data was $13.2 billion with a B, or an average of $499 per record. So these are huge numbers. And we have to ask ourselves, what is at the heart of why these applications are being compromised? And that is because the attack surface for the application environment itself is growing, and it's growing dynamically. And there are three main reasons for that. One is that the diversity of the environments that are applications today in a modern healthcare concern are varied. You have everything from legacy apps running in the data center to virtualized infrastructure underneath your applications, running those applications, and then all the way to the cloud. And those diversity of environments present security challenges given the diversity of how teams have to approach solving the security problem. Second, complex architectures for these applications. Monolithic apps are giving way to containerized apps that are ephemeral. Docker, for example, virtualization, which has been with us for some time. But you have a range of application architectures now that, again, require security teams to stay current. And then finally, you've got dynamic processes around applications. Application environments probably change the most on a regular basis. You have new applications being deployed and coming online in support of these new initiatives, and you have existing applications changing, being updated, new functionality. So the dev cycle is introducing constant change. So when you put all this together, you basically have security teams on their back foot. They're under-resourced to begin with, and this is leading to an ever-growing exploitable attack surface for these applications. So why don't the existing methods solve this problem? Most security is organized around what we would call infrastructure-centric security. And that is, security teams are aligned around layers of the IT infrastructure to secure it. So you have network security teams, you've got server, OS, and software patching teams, vulnerability scans, endpoint protection, all important things, all critical to good security hygiene. But those specific infrastructure elements don't really get at the heart of what it takes to protect applications. Yes, applications run on all this infrastructure, but protecting applications requires a different approach. And one of the ways that you can answer for yourself whether infrastructure security is covering your application environment security needs is to ask a few questions. Can you answer the question about what is the overall application risk posture in your environment? Can you answer the question, which of our most critical applications is carrying the highest risk? Have there been any changes in our application environment resulting in increased vulnerability? Have we segmented our critical applications to restrict network access? And if those apps change, do our segmentation policies dynamically adjust to these changes? So effectively, application environment is different and requires a different approach. So let's talk about what that approach is. First, when you add application security to the mix, the simple idea is that the application becomes the center of the focus, what the application's purpose is, what its behavior is, and the application's behavior is what drives security for each individual application and the environment as a whole. And when you do this, you get a few benefits. One is you get to expose and eliminate all the hidden risks around your applications. As those applications change through normal dev cycle processes, CI/CD processes, your security can change and dynamically adapt to those changes without increasing the risk in your environment. Your team is enabled with real-time app threat detection and response as anomalies happen in the environment specific to changes in application behavior that represents an anomaly or potential threat. You can be notified about that and take action. And finally, you get to monitor the application environment as a whole to understand what your risk posture is across that environment at a specific application level and also across the environment as a whole. And the key thing there is that you can do that using an application context. So business critical applications, you can assess the risk posture and know what the state of security is for those applications and then therefore their potential impact to the business. So let's talk a little bit about what application-centric security actually is. And it all starts with understanding the application behaviors. So if you understand what the application is doing and you understand the known secure state of that application, then you have a very powerful idea, a very powerful concept here, which is that once you understand what known secure behaviors are, any deviation outside of known secure gives you an anomaly, potentially malicious or inadvertent, that you can take action on. And if you use advanced technology to learn over time what application behaviors are normal, and in this case using machine intelligence to understand not just a snapshot in time, but application behavior over time, then you actually end up with something very powerful and new. And we call that adaptive trust. So using similar concepts to the benefits of zero trust, and really zero trust as a stated best practice to get to using less permissive security to provide additional protection, adaptive trust accounts for the dynamic behavior of applications, allows you to move those applications into a less permissive state without negatively affecting the business or the performance of the applications in support of the business. And then on top of that adaptive trust, you have application-aware capabilities and features that give your security team what they need to implement more effective application environment security and to maintain that posture, secure posture. So the first is effectively giving your teams visibility into the risks, the dependencies, the flows of your application environment. They are now able to see a map, a security visualized map of their application environment, all the telemetry and all the information necessary to ask and answer security questions about the environment. Most of the customers that we talk to have very limited visibility into their application environment. And their application environment is often way more complex than they even understand given all the interdependencies. So you need visibility and observability of the application environment as a starting point on which to then layer in security controls that are specific to applications. We call them application-aware controls. And finally, once you've got the controls in place, you now have response or application detection and response where any deviations or anomalies can generate alerts or, if needed, automated enforcement actions to shut down aberrant behavior, kill network access to data, close down credentials accessing high-risk applications. All of this rolls up to a much more effective security strategy for your applications and the ability to maintain a risk posture that is managed and secure for your entire application environment. All right, well, let's transition now to talking about application-centric security in action. Let's use some actual customer examples. But before we do that, I'm just going to give you a little context because the specific use case examples are going to talk a little bit about some of the things that we've done to help our healthcare customers solve this problem. So TrueFort, as I mentioned at the beginning, we're a cybersecurity software company. I'm not going to spend any time really digging into what we do and how we do it, other than to say that our mission in life is to deliver this adaptive trust protection to applications. We, in fact, do the things that I had talked about previously across the entire application estate, whether it's cloud, hybrid, virtual, or legacy. And we leverage pulling in security telemetry that customers may already have, that they're already generating with agents they've deployed using EDR agents such as CrowdStrike. But we also have our own lightweight agent that can generate telemetry from the application environment. So I'm going to jump in and talk about how we've helped a number of companies across a number of use cases. And the first use case is around a top global pharmaceutical company. And their problem was a cloud migration risk problem. So as many of you can relate to, the cloud migration effort is on. Applications are being migrated to the cloud, many in a lift and shift approach. And one of the challenges in making that move in this particular case for this particular customer, but I would say generally this is a problem for these types of projects, is what we would characterize as poor application visibility. Specifically, seeing what applications they have, how they perform, what the behaviors are, understanding the flows, understanding the dependencies, understanding all the attributes of the behavior of those applications so that they can be migrated successfully. And in this particular case, this global pharmaceutical invested over 3 months with a SI, very large SI, attempting to understand and map their application environment. At the end, they had little to show. Why? Well, despite conducting, a large number of time-consuming interviews with application owners to understand the apps, they were only getting a snapshot in time, and they were really only able to get visibility around network connection metrics. And by the time they had actually completed some of the initial cloud migrations, the information was out of date. And because it was a snapshot in time and not a real-time system, many of the applications in post-migration were broken, and the security teams had no way to validate the applications as secure post-migration. So what we did in this case, one of the modules for TrueFort Fortress is called Insight, and what we did for them was effectively automatically generate a behavioral map for their application environment that essentially detailed each existing application, all of its relationships and dependencies and interconnects, and gave them this real-time continuous view of their application environment that allowed the application owners and the security teams and the IT ops teams to collaborate around a single view, and allowed them to then move successfully to the cloud and validate the security state post-migration. In this particular case, this particular customer was using CrowdStrike as their EDR, so we were using the existing agent telemetry that they already had deployed to generate this visualization of the application environment. So we took what was months and months of time invested and reduced it to effectively 1 week and gave them this continuous view and reduced the migration planning time by over 70%. So very successful cloud migration effort. Our next use case is around uncontrolled service IDs. This was a large national retail pharmacy, and you might be saying, well, what does uncontrolled service IDs have to do with application-centric security? Well, the challenge for this customer was that they had a number, in many cases, thousands of rogue and unknown service IDs throughout their application environment. IDs that had been created either through legacy IT processes or out-of-bound IT processes where permission service IDs that weren't under control of identity governance were essentially a high-risk potential compromise exploit for accessing key applications and data. They had no visibility into which IDs were in actual use, even the ones that they knew they had under their PAM system. They still couldn't know exactly which were in use and what entitlements they had. They had thousands of old IDs in use with hard-coded passwords. No easy way to reconcile that without great expense. In fact, the whole effort to resolve this problem was estimated to be a $40 to $50 million effort. And so effectively, this project was stalled due to cost, and yet the risks in their environment were there and potentially exploitable. So application-centric security in this case deals with service identity controls, and that's exactly what we did with this customer. In doing the behavioral profiling of their application environment, and for each application, we were able to inventory and map all of their non-human service IDs. And these IDs were the IDs that were in actual usage throughout their environment. This allowed for the security and IG teams to effectively reconcile these IDs against what was expected. And they could bring the IDs under control, the ones that they didn't know about, they could bring those under control of their existing identity governance. And then further, they had the ability then to lock down the applications from unauthorized access by both the known and unknown IDs. So effectively sweeping up the IDs that they didn't know about that represented high risk for compromise, as well as protecting against even known IDs being used incorrectly through some kind of breach, compromise, and potentially compromising applications and data. So this effectively closed a huge attack surface hole in their environment. It improved their audit and compliance because they were able to, on a regular basis, certify that this process was happening on a regular basis, and they were reconciling any IDs that had been created out of band and bringing them under control. So a actually huge success and a major attack surface reduction. Our third use case is around application integrity and hardening. This was a top retail pharmacy chain who had an existing file integrity monitoring solution that was incredibly expensive for what it did and very limited. It was limited to kind of a batch orientation of file monitoring and change. It didn't deal with all the aspects of potential compromise of application configuration or tampering with malware processes that might be tampering with binaries in an application. There was no way for them to automatically enforce when there were detections of modification of critical system files that would compromise the application. And then finally, they had no way to benchmark their applications and workloads from an application workload perspective without a huge amount of staff time, very difficult to scale for the number of applications that they had. So they didn't have a good solution to this problem. And again, application-centric security is really, delivering effectively runtime, what we would call runtime integrity assurance control. And in this case, in addition to file integrity monitoring, we were able to add configuration monitoring and application process level monitoring. So a much more comprehensive level of application integrity, file configuration and process than what they had previously. And we were able to continuously monitor and automate enforcement actions for shutting down access to any attempts to modify any of these sensitive files. So automated enforcement. And then finally, integrated CIS benchmarking for all their applications and workloads at scale was another component of the solution. So effectively, this moved them from a very reactive posture to a much more real-time posture. And in the event of any modifications, inadvertent as they may be, they were able to implement automated rollbacks to the compliant state. And again, more easily address audit and compliance reporting requirements around application integrity and hardening. And our final use case is around microsegmentation, or as we like to call it, intelligent application segmentation. And in this particular case, this was a large national healthcare insurance provider. And their problem was that effectively their attempts to microsegment were often difficult, and the projects were failures, mostly because of the time-consuming process that they had to try to identify all the critical apps and dependencies as a starting point for their segmentation project. And the segmentation policies that they were able to put in place were very brittle and difficult to maintain, and therefore extremely expensive to maintain. And as a result of this, they often had errors in those policies as applications changed in the environment. And those changes required manual processes for updating policies. And that process resulted in oftentimes, negative business impact, because anytime there was a policy change and network access was blocked due to a change, an inadvertent change, or a policy that wasn't updated properly, or an application change, then there was essentially a negative business uptime impact. So application-centric security in this case makes the application, as I've discussed, the center of the universe, and using the behavioral understanding of what the application is doing, you're able to essentially map that application environment, make it visible, and use the behavioral understanding to identify and group the high priority applications, in this case, high trust applications. Secondly, the adaptive trust profiling that I mentioned earlier, combination of behavioral profiling and machine learning, allows for better segmentation policies that can be automatically generated based on that behavioral understanding. And because of that, it's easier to enforce that segmentation policy based on the actual flows and interactions between the applications and their components that are part of the segmentation group. And if the applications change and are updated, then segmentation policies can be automatically and dynamically updated rather than requiring manual process, which saves a huge amount of staff time and reduces error, reduces business downtime as a result of segmentation policy errors. So when you put all this together, application-centric security really brings a dramatic reduction to your attack surface. Effectively, one way to think about this is this behavioral understanding of each application is really, in a way, generating a trust perimeter for each application. Each application is doing what it needs to do and enforcing that trust perimeter to be as minimal as possible. So therefore, the exploitable attack surface on each application is reduced, and as a result, the overall application environment risk and attack surface is reduced. And then secondly, security teams are able to move from the reactive posture that they exist in today and move to a more proactive stance. And that, in combination with shrinking the application trust perimeter, effectively gives you a much reduced attack surface in your application environment. So lastly, what should you look for in an application-centric solution? So first, you need to look for the capabilities that give your team the visibility, application-aware controls, and application detection and response features specific to targeting applications. You need to look for behavioral analysis of the applications and basing security on the behavioral profiling of applications and the machine intelligence to maintain that learning about how the applications are changing so that the security state for your application environment is also maintained. Thirdly, it needs to be comprehensive. It needs to cover your entire application estate, whether it be new cloud applications, hybrid applications, some running on-prem, some running in the cloud, connected virtualized infrastructure for applications, or just traditional apps. The solution really needs to cover the entire breadth. Otherwise, you're just getting a single siloed view of one part of your application environment, not the holistic whole view and protection for your application environment. And lastly, it needs to be real-time and continuous. Real-time is critical. Obviously, any anomalies that are detected need to be detected right away, and alerting and or automated enforcement actions need to take place right away to shut down any lateral movement or breach-related exploits that are active in the environment. And with that, I will thank you for your time and thank you for participating and joining me today. And if there are any follow-up questions, then by all means, please reach out to TrueFort, and we'd be happy to talk to you further. Thanks again.